between the two there and another gap there. What the auto manufacturer wants is when you sit in your shiny new motor vehicle, you're going to look at it and everything is going to look top quality. What they don't want you to see is any deviations in those gaps, anything that gives you the impression of low quality.
Yeah,
so
like my real leather, I want that stitched to perfection.
So we can measure things like this, the groove between the leather there, and make sure that's consistent. We can measure that, we can check that this airbag unit is centrally located in the centre of the wheel.
Okay.
So it's all about perceived quality, making the wheel look as good as possible.
Absolutely. Now, cobot, so if I touch this, it's going to stop?
I'm sorry?
This is a cobot, so if I touch it, I just want to clarify before I touch it.
Yes, yeah, this is a cobot, so it doesn't need any safety devices around it.
Excellent, so there you go, stop it.
Yep. So
that's broken the whole demonstration, sorry about that.
So that one else, but that's absolutely fine.
Brilliant, so I'll get in my car and it's all looking perfect, so the tens of thousands of pounds, tens, not hundreds of thousands of pounds, I reiterate, because I haven't got a posh car, it all looks absolutely perfect thanks to your robot and your scanning device.
Absolutely, that's right.
Nice and simple, there you go.
This technique is applied to the bodywork as well, so whether it's body in white or the finished vehicle, we'll be looking at panel gap and flush,
So it goes to all sorts of different applications?
Absolutely. So
just automotive?
No, 60% of our business is aerospace. So it could be aerostructures, where we could be looking again panel gap and flush again, but we could also be looking at edge features. So it might be features on turbine blades, for example.
So I'm thinking this will go super accurate. And micron tolerances.
Yes, we have different sensors available. The sensor on here is what we call a T60. That's got a 60mm field of view and will measure to an accuracy of around about 25 microns. If you can live with a smaller field of view, we could use something like our new T15 sensor, and that's going to give you an accuracy down to about 5 microns. So pretty precise measurements for this kind of application.
How was it done before?
Hand gauges, little plastic wedges or feeler gauges and this sort of thing. So very monotonous, very tedious and prone to operator error.
So you're getting someone out of doing that role and doing something far more interesting.
Exactly, absolutely.
Brilliant. Okay, I'm going to stop you there. That is a fantastic bit of technology. Could you hand your microphone back to Chloe, please? And thank you very much. We're going to move